Alrighty. Hey everyone, welcome back to Soft Spoken Scientist. Today we're practicing how to factor quadratics, and these examples are going to include both simple trinomials, where the coefficient in front of x squared is 1, and some slightly trickier ones where that coefficient is greater than 1. Don't worry, we'll take it step by step, calmly and clearly, so you can follow along at your own pace. Let's get into the practice problems, alright? But before we do that, I'm going to go over this quadratic with you guys that I think you should know. So you have x squared plus bx plus c. This is like a formula you guys need to like drill into memory. So this would represent, the a. This is bx, and then that's c. So this is, c represents a number, okay? Any number, like 7, 8, 9, right? The b, let me start with that. The b is a number as well, like 12, 20, okay? And then this is just x squared. Now, like I told you guys in my last video, there is a number in front of x squared. Even though you don't see it, it's 1. I wish someone told me that when I was in school. Okay. So let's scroll down. I'm going to write this down. There's a 1 here, okay? So they're going to give you on a test this type of problem. They're going to be like, factor. And you're like, wait, what? But you're going to say to yourself, okay, this is the a in the equation. This is the b. And then that's the c, right? So basically what you're doing is like c times a. And you're going to say like b. And people think, what's going on? I'm about to explain. You have to ask yourself, the last number without the integer, without the variable, is 12. Then you got the 1, right? You're going to say to yourself, 12 times 1 is what? I took the first number and the last number. 12 times 1 is 12. So I'm going to say to myself, what multiplies to 12? That is the worst multiplication sign you've ever seen. What multiplies to 12, but it's going to add to 7, which is like the middleman right here. And I'm thinking about it. 12 times 1. No, because 12, nope, it's not going to work. That would be 13 if I added it. We got 6 and 2. No, because 6 plus 2 is 8. And then I got, like 4 times 3. Well, that's 12. That adds to 7. Oh my gosh, that's special. So I'm going to write 4 times 3 is 12. 4 plus 3 is 7. So now I got to break this beautiful formula, this equation, right? I'm going to bring this down. And this is just like a song. You kind of just got to know it. X squared, and with practice you will, 7x, right? I'm going to break this up into 4x plus 3x. Because what's 4x plus 3x? 4 plus 3 is 7. Carry the x, 7x. That's it, you guys, okay? And I just brought this and this. All I did was bring them down. Okay? So I have x squared plus 4x plus 3x. I'm going to bring all of that down, plus 12. So x squared and 12 are brought down. You break b into 2 pieces. It goes from 1 piece to 2. All right? So then you have this formula. And you're going to say to yourself, okay, I know it seems funky. You're going to break it in half. Okay? And you're going to say, let's start with the pink. You're going to say to yourself, what does x squared and 4x, what's like the greatest number or integer I could pop out of it? Well, I know x squared and 4x both have x in it. I think we all agree on that. So x is going to be on the outside. Just bear with me here. You're going to put a set of parentheses and ask yourself, x times what gives me x squared? And you're going to say, well, x times x gives you x squared. And the reason I knew that x times x equals x squared is because they're both raised to the first. It's just invisible, y'all. What's 1 plus 1, you guys? 2. So we got x, parenthesis x, and then plus 4. Because x times 4 is 4x. And that looks just like that. Now, I'm going to say plus 3. Okay, look, I just brought that 3 down. And I'm going to say x, because positive 3 times what gives you 3x? X. 3 times what gives you 12? 4. And here's a little rule. The inside parentheses always match. Do y'all see that? X plus 4 on the inside, x plus 4 on the inside. That's how you know you did it right. So you're going to say x plus 4, x plus 3. This is your answer. You survived. That is how you approach one of these types of problems for factoring. Let's do another one. Maybe a different one. Let's do something a bit more challenging. What if you had a number that was, I don't know, in front of x squared that wasn't a 1? It wouldn't change the story, you guys. So it would be 3 times the first number in front of x squared. What's 3 times 2, you guys? 6. So I gotta ask myself, what multiplies to 6 but adds to 7, y'all? What's 6 times 1? 6. What's 6 plus 1? 7. Do y'all see that? It's magic. Okay, so you got 2x squared plus, I could say 1x, or I could say 6x. It literally doesn't matter, you know, at least not yet. I'm just gonna put 6x plus x plus 3. 1x for y'all who want it. I'm gonna break it in halves again. I can pull out a 2x, and then I have x left. And then I can pull out a 3. Because 2x times x is 2x squared. 2x times 3 is 6x. Plus, and then I'm not even gonna, I could just rewrite it if I wanted to. Because remember, they gotta be the same on the inside. And then I have to say, okay, what would be enabling us to have x plus 3 on the inside? X plus 3 times what will be what it is? And I say to myself, well, 1, because 1 times x is x plus 3. 1 times x is 1x, that matches. And 1 times 3 is 3. So I have 2x plus 1 as one answer. The other one would be x plus 3. There you go, guys. All right, and that is how you solve these types of problems, okay? Great job working through these factoring problems with me today. Quadratics can look intimidating, but once you practice a few different structures, especially when the number in front of x squared changes, everything starts to click. If this video helped you, please like and subscribe so I can keep making calm, simple explanations for you. And remember, STEM is for everybody, especially you. I'll see you in the next lesson.